So I'll stop my video so the bandwidth isn't an issue on my end, and I'll start moving forward with the presentation. And since we're a small group, if we have any questions during the presentation, please just feel free to just interrupt me, not a big deal at all. So again, today we're going to talk about mitigating the risk of aerosolized contagions as we discussed briefly. And I'll give you a rundown of who Erlab is. We're a company that's 53 years old, focusing on the effectiveness and ventilation effectiveness through filtration. And we provide many solutions. Everything we do is through filtration. So we don't tie into the building's HVAC with any of our products. With that, we provide filtering fume hoods. As I mentioned, we focused typically on laboratory settings. This pandemic has really outstretched our markets that we are able to provide solutions for. And that would be with the Halo air filtration system that you see in the ceiling grid. And then we have whole room air pollution sensors. We have storage cabinets, powder weighing stations. So as you see, we can outfit a complete lab with filtered solutions, especially while they're doing their science experiments. But specifically, we'll talk about the Halo, which was designed to capture fugitive emissions in a laboratory, whether it be volatile organic compounds. And now we are able to adapt HEPA filtration to help us with the aerosolized contaminants, which is COVID-19 and other viruses, as well as generalized pollutants. So obviously schools today focused on how do we get kids back to school? How is this virus transmitted? We know a lot of things about this virus, and we certainly know, we don't know a lot of things about this virus, but what we do know is that you get contact transfer infections and then you get aerosolized infections. And what is the difference between the two? Contact transfer is due to droplets that come out of the mouth when somebody coughs, sneezes, or even yells or talks loud. Those droplets end up coming on the surface, and now you touch that surface and you have contact transfer. Those droplets also become, as they desiccate and evaporate, they become droplet nuclei, especially if someone sneezes. That droplet the heavy ones will fall down and the smaller ones will actually remain suspended in air, which is called droplet nuclei. And that's how aerosolized contamination occurs, and that's what you breathe into the lungs. So, and that happens obviously with a person's saliva, as well as, unfortunately, studies have found this to be the case with fecal matter and bathrooms. So there's many different aspects we have to look at in how we provide a solution to remediate the risk of this aerosolized contagion, which actually ends up being the most severe infection that we can get, is from the droplet nuclei. Now, when I have a conversation, and I assumed that when I built this presentation, I was going to be talking to a lot of facilities directors, or those who are concerned about what is my mitigation plan or the room level prevention plan for my school. So the questions I have asked, and I will answer those as we move forward in the presentation, is first, is there a room level prevention plan? Can the building's HVAC system handle an increase in air exchange rates per hour, which is called ACH? Or, and more importantly, an upgrade to at least a MERV 13 filter. And that's a filter that's been rated to help capture some of those droplet nuclei. However, it is not the most efficient filter, but as per ASHRAE recommendations, they want the building's HVAC to have a MERV 13 filter integrated. The third question is, are dampers able to be adjusted according to air circulation needs between 50 and to 100%? And that's basically dampers that will allow more fresh air in. And if you do have dampers, what is the plan to maintain relative humidity? Today here in Massachusetts, the last 3 days, it's been unbelievably humid. And if we relied on dampers, we would have humidity issues. Unfortunately, when your relative humidity increases above 70 to 80%, that inhibits growth of mold, viruses, and bacteria. So we want to make sure we're able to maintain relative humidity. And can you zone the building's HVAC for room level purging or decontamination? Does it have its individual settings for is not being centralized? Goes one main filter, and as it goes to that filter, it actually to other areas of the building. Do you have controlled directional airflow patterns? What do I mean by that? dirty to clean airflow patterns. How is that airflow directed? Is it directed horizontally and things of the students, faculty, and teachers, or does it go up vertically away from the breathing zone? And if your facility is ventilated, what is the plan to reduce allergens and other pollutants which contribute to sick building syndrome and compromising of the immune system? So there's a lot of factors we have to look at when we look at a mitigation and prevention plan. Now the next, because the droplet nuclei, and this is what I mentioned before, are so small, they're deeply inhaled into the lungs when breathed and straight to the air sacs, which increases the severity of disease and causes lower respiratory infection as opposed to an upper respiratory infection, which is typically what happens when you're exposed to a typical droplet or contact transfer infection. That's why the aerosolized contaminant ends up being more critical to the person who does become infected. So this diagram will actually show you what happens with those aerosolized contaminants, how they bypass through the room into the HVAC system and then actually impact an area in which no infected person existed. And then as it moves forward, it shows you what the halo does to mitigate and capture those droplet nuclei, which is critical to, again, reducing the risk of aerosolized transmission. So it takes those contaminants up and then it disperses clean air back into the space, allowing the clean air to then go into the return vents and then therefore not impacting the other rooms or areas within the facility. Now, again, remember, this is all independent from the building's HVAC. It is run on 50 watts of power, standard 110 volt, and it's filtered with an H14 HEPA filter or a U17 ALPA filter, which is laboratory grade filters used in biosafety cabinets, operating rooms, and such. So these are very reliable and efficient filters that we use in any of our products. And so this system also can be integrated with carbon filtration in addition to HEPA filtration. So you can have a carbon filtered halo or a HEPA filtered halo, depending on what we're looking to capture. As I mentioned, laboratories has been our focus for over 50 years. So as you can imagine, we've dealt with a lot of different VOCs and chemical pollutants, but we've also dealt with a lot of different particulate pollutants, such as things as dangerous as fentanyl, things as dangerous as going to market drugs that we're not sure what the adverse side effects are. So we've been exposed to many different things in the laboratory. So understanding viruses and how to capture the particles is certainly part of our expertise. Now, this product can also be integrated. We can also integrate an optional ionizer to help disperse ions, positively and negatively charged ions, to attach to any contaminant that exists and basically rob it of its life-sustaining hydrogen. So there's a lot of options with this product. For every 2,500 cubic feet of space, so basically a 250 square foot room, 300 square foot room really, and with 10-foot ceilings, you would need a halo per every 300 square foot room. And that would provide you with an additional 4 air exchange rates per hour. It's always on 24/7, so you don't have to worry about turning it off and on. You don't have to worry about a student flicking a switch and then having the unit not run. It's operational 24/7, but it can be monitored, maintained through a web-based portal where you can direct connect to an IP address and have full ability to turn the unit off and on or switch the modes in which it can run on if necessary. However, we highly recommend leaving it on 24/7. That's where the true value is having it work and continuously purge and clean the room. As mentioned, again, totally independent from building HVAC, and I harp on that because not a lot of people understand that you don't have to utilize HVAC, which becomes extremely costly. And it consumes very low power, 50 watts of energy, which estimates to be around $50 per year for each halo. So extremely green friendly as well. So let's talk a little bit more about ionization and how ionization works and why we would want to integrate an ionizer. Where we capture the particulate aerosol contaminant is critical. You also need to look at this as a multi-tiered approach. Ionizers aren't necessary for this product to work, but it allows you with a sense of comfort knowing that if I have ions dispersed or even UVC dispersed, which I am not a huge fan of. I prefer ions because of the level of ozone that is not emitted from ions. It provides again, a sense of comfort knowing that you have these ions dispersed, attaching and grabbing to the RNA particles to rob it of its life-sustaining hydrogen. Some people may say, well, if I have ionizers built in even to my HVAC system, why would I need to capture the aerosolized contaminants? Isn't the ions working to decontaminate or essentially, again, kill the virus? Yes, but there is a kill rate issue. Like anything, whether it be UVC or ions, it typically has a kill rate between 10 minutes to a half hour, depending on how strong the nanogram of UVC is and how many ions are dispersed. Now, between that 10-minute mark to the half-hour mark, you still have an active contagion. So you have to, if you're going to rely just on ions, you have to look at it from that approach. Is if somebody coughs or sneezes, that contagion is immediately dispersed, immediately aerosolized, and that ion is not going to provide a quick means of disinfection. It's going to have a proper kill rate to be effective. So it is still absolutely critical to capture and contain the aerosols. And even with ions, you have to make sure that you still have surface level decontamination wipe downs, protocols that I'm sure the schools are now implementing per every class. I don't know what the implementation standards are. I know you're probably still working them out. But even with ions and even with the halo capturing and containing the aerosolized contaminant, you still need to have your proper wipe down protocols put into place. So the next few slides shows the overall ventilation effectiveness of the halo. And basically it shows you with the halo off, test studies performed, and then with the halos on, the same test studies performed at 4 air exchange rates per hour. And again, the air exchange rates per hour is how many times per hour you have fresh air entering that facility in that space. So the slide to the left will actually show you the results with the halo off, and you see a spike in concentration. Now this concentration was measured with acetone, but acetone acts very similar to a particle, so that the results would be very similar. However, in order to detect and show you results, it's best to show you ppm values. We do have studies with particles and COVID-19 reductions that will be available to you by the end of the week. It's actually being performed by this company, 3 Flow Systems, as we speak. But basically what it shows you is a spike in concentration with the halo off, and then a decay time. So basically the decay time is how long it actually took that spike in concentration and that pollution factor to be reduced down to low level concentrations. Now this spike in concentration is critical to look at because that's at the point in which you're exposed at your breathing zone to these potential contaminants. Now we wanted to run that same test with the halo on at the same 4 air exchange rates per hour, and the results were staggering with a reduction from 12 parts per million down to about 3 parts per million at the peak of concentration, with a decay time of about 800 seconds. So extremely efficient at mitigating the risk of any type of contaminant, whether VOC or particulates. But then we wanted to take it a step further and said, well, what if we increase air exchanges? Because that typically always seems to be the response. Well, if I just increase my air exchanges, well, I'm adding more fresh air into my space. Isn't that going to take care of everything I needed to take care of? What you'll see here is the answer is no. What happens when you increase ventilation is you actually increase turbulence. So you see the spike in concentration actually increased, because when you create a turbulent environment, you're actually blowing up the things that are on the desk, the desktop chemistry, the contaminant that's on the desk or the work surface, and now that's all being blown up again towards that critical part, which is your breathing zone. But then we've said, okay, we saw a spike in concentration at 6 air exchanges with the halo off. Let's see what happens with the halo on. Well, as you see here, we went right back to about 3 parts per million at the peak of concentration. Why is that? So the halo, as it drives air up vertically, it also disperses it horizontally across the ceiling, creating what's called a Coiro effect of airflow. It's basically a mushroom cloud. So we create a clean sweep of air, so dirty air up, filtered air horizontally, and then it drives itself back down. It sweeps the dirty spaces, and then it brings it back up vertically to capture and contain, which allows us to kill the dead zones and reduce the level of turbulence in the facility. Ultimately, the results was an 80% reduction in average concentration in the facility and a greater than 30% reduction in outside airflow. So the answer is clear. Increase in air exchange rates is not the answer to mitigating the risk of contaminants. Now, a solution for today and tomorrow. Why do I say that? So as I mentioned, we've been focusing on providing protection for laboratory personnel for over 50 years, and we want to eliminate the risk of exposure to any type of contaminant. Well, now with this unfortunate pandemic that has hit us so hard, there's been many studies done about the global burden of disease and how it's attributable to ambient air pollution. This study was done back in 2015 of this article that I can certainly send you links to after. And then a recent study that was done by Dr. T.H. Chan from Harvard, linking COVID-19 specifically to air pollution and unfortunately the death rates. So what we're finding, and you can just Google this and you will get hundreds of articles linking air pollution to the infection rate, the severity of infection rate, and unfortunately the mortality rate of COVID-19, because air pollution and what's called PM2.5 are all the little particles that we can't see, that we breathe in daily, that actually compromises not only our immune system, but our lungs' functionality to ward off respiratory illnesses such as COVID-19 or any SARS-related illness. And this graph just shows you the increase of air pollution from 1990 on the bottom to 2015, and that has just increased 5 years later. So we have to look at what can we do to, again, reduce our exposure, at least in the indoors, because indoor quality becomes just as dirty as the outdoor air quality. As when we increase those air exchange rates per hour, guess what we're bringing in? Dirty air from the outside. So we want to minimize our risk. So when I say a solution for today, yes, that the product and the halo would be installed in your facility today, but it's going to provide a solution forever. Always working to capture any type of pollutants in the ambient air atmosphere. And then study results underscore, obviously, the importance of continuing to enforce existing air pollution regulations to protect our health. So there's a lot of things, a lot of benefits behind filtration in the facility. Now let's talk a little bit more about PM2.5, because not everybody maybe has researched it or dug into it the way we have. We must understand the effects of it. So everybody on the call understands micron size. The smaller the micron, the less you can see. Beach sand's about 90 micron, human hair is about 50, dust, pollen, mold is about 10, and then PM2.5 is all those microns and below of what you can't see and what really impacts us. Goes into our air sacs, our noses can no longer filter it, our mucous membranes can no longer filter it. It goes right deep into our air sacs in our lungs and attributes to chronic disease such as asthma, bronchitis, heart attacks, respiratory problems in general. And again, exposure to PM2.5 is linked to higher COVID-19 infection and mortality rates, and that can be seen right on the NIH.gov website. Again, there's just article after article after article. So as I mentioned, we're here to try to mitigate the problem of today, but also provide a solution for tomorrow and cleaning up the air we breathe in general. So in summary, I obviously like to leave it for it's open for discussion after the presentation, but in summary, filtration and ventilation effectiveness is critical to reducing the aerosolized spread of viruses while also significantly reducing generalized pollutants such as PM2.5, making the air we breathe healthier, thus making us healthier and better able to ward off respiratory illnesses and disease. A multi-tiered approach should be taken to mitigate the risk of viral exposure. There is no silver bullet to warding off this virus. There's going to be a multitude of factors working together to, again, help mitigate the transmission of this virus, which will include surface level contact transmission. That still needs to be a concern. And yes, while upgrading HVAC is absolutely a solution, I know many facilities are looking at multiple solutions. It is extremely costly and it does not provide room level mitigation and relies on dilution as part of the solution, risking multi-room exposure, as you saw from the animation that I showed you earlier on in the presentation. So with that, there's a lot of information I provided as quickly as I could, so everyone on the call could hear it. I know some had to run off, but please, any questions and answers, I will be glad. Any questions, I would like to answer.
Hello, Jesse.
Hello, Jesse.
Hi, Ted.
Hello. I have a question about the MERV13. So that's a two-part question. Where they are physically located, if they install it in the HVAC system, and what's the difference between the MERV13 and the HEPA H14 and the Halo?
So good question. MERV13 filters in the HVAC system are typically installed centrally. So at the blower, so at the exhaust, which means the air has to travel to that MERV13 filter. As far as efficiency, the MERV13 is about 75% efficient, give or take, depending on how much CFM is blown through that filter at capturing viruses and generalized pollutants, whereas the H14 filter is 99.995% efficient at capturing viruses from 0.1 micron and lower. So it's much more efficient than a MERV13. MERV13 is more used for industrial use.
Okay. Jess, it's Frank, the Peyton Group.
Hey, Frank.
I got in a little bit late. Were you able to go into any of the software that it's included to monitor the filters? Have you shown that already?
Nope, I can certainly do that. Let me just pop it up.
I think it's important because the teachers can see, they can program them to be turned off at night. You know, your certain schedule where more kids are going to be coming through, so they can kind of, I know the filters last about a couple of years, or is it like 3 or 4 years, depending on, you know, the area. But I think it's important to show this because it shows how you can preserve the lifespan of the filter.
Absolutely. So the filters last typically about 5 years. Now, if it's in a wood shop, it's going to last less. It's not that the filter does not become efficient and it loses its efficiency. Quite the contrary. As it becomes clogged, it becomes more efficient. On the HEPA side, on the carbon side, that's not the case. But on HEPA side, that absolutely is. It's a matter of static pressure drop and what can the fan handle. What can the fan handle as far as static pressure? All right. So all of these systems that I mentioned, whether it be the Halo or any of our hoods, our filtering fume hoods, are integrated with what's called smart technology. And allows, you can see it now?
Yep.
Yeah. And it allows you to monitor the performance criteria of the product. So what you see here, this gauge in front of me is actually a Halo that's running in our Inspiration Center, and it's monitoring air quality. Obviously for air quality, we're detecting specifically volatile organic compounds for this specific Halo, and it's also monitoring the fan. Now, if static pressure drops, if a HEPA filter becomes clogged, you'll see this fan gauge go to the red, and there'll be a soft LED band of light around the Halo that will pulse to alert you that it's detected an issue with either pollution spikes in the laboratory or mechanically with functionality of the product. So you can log into every one of your Halos. It's simply, I say simply, although I know it's not as simple, but simply tied into the IT infrastructure. You assign each product an IP address, and you can log on to every product that you have in your facility and monitor every single one to see the performance criteria. Here is where you can change your the modes of how the product runs itself and the fan speed. However, we set them from the factory based on the filter that is integrated into the system, and we highly recommend that it's on 24/7. But you can change it to day-night, so the RPM speed of the fan will reduce it during the nighttime, and during the day ramp back up. You can change it to min-max, which means if it detects a spike in concentration on the chemical side, it will actually increase the fan speed. So there's a number of different options you can program the Halo for, but for what we're talking about today for virus mitigation, 24/7 activity is what's highly recommended.
Great. I think that's powerful. Also, a lot of these people that are attending today and yesterday and tomorrow have labs with high ceilings. You showed an example. I know you went up there, but how you could hang them from, you know, the high ceilings with chains.
Absolutely. Yeah, we can hang them with, so I'm going to actually flip my screen around. I'm going to stop sharing my screen and I'm going to take everyone into my inspiration center and show you how a halo is actually installed into the ceiling. And then I'm going to go upstairs into our old laboratory where we left the halo hanging purposely by gripple hooks and an open ceiling. So let me just flip my screen here and you'll be able to see. So there's a halo that's integrated into the ceiling structure. It's basically ties in just like a fluorescent light. And that's the LED band of light that I spoke of earlier. When it's steady, the product's performing at operational performance. If it pulses, that means either we've detected static pressure drop or we've detected a spike in pollution in the facility. And then we have other halos here that are not on. I have them shut off because we were running a couple tests here in the lab. But you can see, just to kind of give everyone a visual on the call too, this is our inspiration center. So these are all of our products. Again, nothing is tied to the building's HVAC, completely independent through filtration. Now let me just take you upstairs and I'll show you what the halo looks like if it has to be hung from an open ceiling because you don't have access to suspended ceilings. Let me just run up real quick. All right, so, and here's the halo would hang in rafters. If everyone can see that okay, with gripple hooks. It's about 60 pounds with the filter in it.
Is that 110 power?
Yep, 110, 50 watts. That's how we would hang it in open rafters. Now, the higher the ceiling, the more volume of air we have to process, which means the more halos that would be required in that room. So we always request the ceiling height when we're looking to outfit a facility to determine how many halos will be needed to be as effective as it needs to be to mitigate the risk of transmission.
I like that. Thank you. Thank you for showing that.
You're welcome. Any other questions?
We're doing a promotion on these halos for the people that are attending. We're doing $31.99 per halo. Usually an installation is around $500 per halo. We can probably take that and cut it in half if we have more than 3 or 4 of them. But this is something that obviously could be purchased with CARES Act money, although that's probably expired now, but there's probably gonna be another round of it, hopefully.
Yeah, there actually will, Frank, and I'm sorry to interrupt. I was on my way in today listening to the news, and they're gonna release $70 billion as an additional round of the CARES Act to hopefully help schools get the equipment necessary to get students back into the school, which I loved hearing that because it's, if we're going to try to mandate students going back, we better subsidize the school somehow to get them the right tools necessary to have teachers and parents and students comfortable going back to school.
100%. Not only that, it's going to, even let's say in 6 months when this virus is hopefully eradicated and we got something else going on, it's going to be there for the long run. It's going to be there for other, whether it be SARS or COVID or basic flu. It just makes it a cleaner environment for the teacher, for everybody. So if there's CARES Act money, you got to get your quotes in now. Just get a hold of Chris or myself. But this is an amazing product. I think it's very much needed. Everybody has to do as many things as they can, whether it be wearing masks, putting up dividers, get a filter, do everything they can to make it a safe environment.
Well, absolutely. Yeah, as I mentioned in summary, it's a multi-tiered approach, right? There's no silver bullet. There's got to be a number of different solutions that need to be implemented in order to do our best and do our part in mitigating the risk here, so that again we can hopefully get back to some sort of normalcy. I don't know if we'll ever be where we were, but I'd like to think we will be.
Yep, and the nice thing that Peyton Group has merged with H2I Group, which is actually a construction company. So we have the manpower to do the installations. We have offices all over California. We have offices in all over the United States, but so they have all the installation base to get this done pretty quick as well. So I think it was great again to have you on. I appreciate your time. Any more questions for Jess?
And if you're shy, you can certainly chat me too. I'll read off your question.
Did you give out your email? I guess they can email us, but
yeah. So my email is here. So jcoiro@erlab.com. You can reach out to me or our main 800 number.
Where are you based out of? What's the main company based out of?
So we're in Raleigh, Massachusetts. That's where I'm based. I also have Ted Piccio on the line. He's our West Coast manager. So he's based in San Diego. We have a number of other regional managers throughout the country, but myself, I'm here based in Massachusetts.
Great. Well, thank you again. I think that it's an amazing product that we can all use. So I think we're going to put some in our office here too. So.
Excellent. And I got a few chats. Hold on, let me just read them off. Some questions here. Oh, that was Ted sending to everybody my email address. Ted, if you could send them your email address as well.
Okay.
Extract that from the chat box. Thank you, Ted.
All right. Well, we're done a little bit early, but that's okay. We got everything we wanted to see, I believe. But are these items in stock in case we order them? I got a couple orders that we're expecting. Are they pretty much available, or you got to wait, or what's the ETA on shipping?
ETA will be end of August. We were obviously the demand is extremely high, so we have a supply chain, not an issue, but we have a supply chain delay. But we have more coming in at the end of August.
Where are they manufactured?
So they're manufactured at our facility in Normandy, France, and in Kunshan, China. So we have two manufacturing facilities right now. And we're looking to outsource here in the U.S. It's just time is of the essence right now, so we have to utilize the manufacturing plants we have.
And I know we didn't talk a lot about, you mentioned you needed IP addresses, but you mentioned possibly having a Wi-Fi connection down the road, maybe
Yeah.
in a year, or what are we looking at? Because a lot of our schools aren't going to be able to go back to school, most of them till January anyway. So that gives us a little bit of time to prepare, but how are we looking for that product?
So that's a good question. It's kind of a loaded question because I don't want to give you unrealistic answer here. It's in development because we're not just going to be adding near-fi to the product. We're also going to be changing the footprint of the Halo to fit in a 2x2 grid and to allow the adaptation of carbon and HEPA into one unit. So it's a little bit more of a change than just adding near-fi or Bluetooth. So I would think realistically, though we're trying to really expedite this, I would think realistically mid-2021.
Okay, that's fair.
Yeah.
Well, thank you again. If anybody has any further questions, you can get a hold of Chris and myself. But great presentation. We'll do more of these as we continue to get people back into school. We're going to have a lot of need for this product. So thank you again.
Thank you all. Have a great day.
You as well. Take care.
Bye.
Thank you. Bye.